Bismillahirrahmanirrahim. I am Muhammad Zahid, and today I am here to present on a topic an ultra miniaturized implantable antenna for gastrointestinal tract monitoring. I am a co-author of this paper that was accepted for this conference. Let's start. I will start from the introduction of the antenna system and implantable antenna and uh, that is used in biomedical devices. Antenna is a device, the simple definition of an antenna is a metallic piece that can transmit and receive electromagnetic waves or radiations. So if antenna is used in a medical devices that will be inserted in our body to check different parameters, that's called implantable antenna. So antenna will be used in medical devices placed in a human body, and implantable medical devices play an important role to diagnose a disease. Also used for monitoring of human health. The implantable devices collects the data from the human body as well as tracking the health and the features. For example, to check the BP level, to check the cholesterol level, to check the insulin level, whatever the application we want to track. Antenna system sends the data to the external unit, like the device that is outside the body. And now, what are the difficulties in designing the implantable antenna? We have to design an antenna, and that will be used in a device. That device will be inserted in a human body. So that we have to take in account the antenna size should be small. The first point is this, and the desired bandwidth, like which band we are trying to fix and achieve. Sufficient radiation efficiency and the radiation pattern, and they should be antenna flexible. That depends the flexibility of medical devices, and specific absorption rate that lies in a certain range, as well as antenna gain. These are the frequency bands that are used for the biomedical devices and recommended by Federal Communication Commission. The first one is ISM band 2.4 to 2.5 gigahertz, med radio 400 to 406 megahertz, and the second ISM band is the next one, or the lower ISM band is 902 to 928 megahertz. Why we choose the implantable antenna? For what? That is an emerging technology, and it is for the betterment of human health. A lot of inventions to do. So the proposed work is for what? The implantable antenna covers the first ISM band 902 to 928 megahertz. The overall bandwidth of this antenna is to be covered, that is 26 megahertz. But our antenna has covered more bandwidth. And the basic component is what? In the microchip patch antenna, we are going to use the basic three components. The first one is dielectric material. In other case, you can say it's a substrate, and the bottom of this substrate is a ground plane, and the top of this substrate is a radiating patch. We use a technique that is a shorting pin to miniaturize the size of an antenna. So the antenna has been designed in a rectangular shape, like it is. We are using the dielectric material that is Rogers Ultralung 3850HT that has the dielectric constant is 3.14. The same material used for substrate and superstrate. Why we are using this material? Because this is biocompatible and it is a flexible substrate recommended by the company like manufacturers Rogers Corporation. Antenna gain gives a like flexibility due to its thickness. The thickness of this substrate is 0.1 millimeter. So as we already discussed, we are used to use the shortening pin for the miniaturization of the antenna, and that gives a strong current density near itself, like power by using the shortening pin. Where we use the shortening pin, there is a more current density to increase the bandwidth. Like this, from the figure, the left part is showing the patch on the top view, and the right side showing the bottom view. So to achieve the results, we have followed different steps, like from the step 1, 2, 3, 4. The step 4 is actual, the final result. We have followed the steps from step 1. There is no band. So from the step 2, we have achieved the band at the higher frequency. From step 3, the higher frequency band shifted to a lower frequency. In the step 4, we had achieved the resonance at what frequency that we needs. There are the effects of the slots that we have used in the patch and the ground. From the previous figure, we have used the different slots in the ground, and from this one, on the patch, on the top side, on the top layer. Also, sorry, we also use from this figure the 4 steps followed, like from 1, 2, 3, 4. In the step 4, we have achieved and the resonance at a certain frequency. So, effect of the port radius, like from this figure, you can check this is the port, and we use the port radius. In other case, you can you can understand we are trying to use the port that have the impedance of 50 ohm in a standard case. So we are changing the radius to what? To achieving a 50 ohm impedance. So this is a proposed work that we have achieved, and we have designed this antenna and checked this antenna using a phantom that have the properties of different body parameters by changing the dielectric constant, by changing the homogeneous phantom and the different dielectric properties, the skin, stomach, and different others. And we have checked the reflection coefficient in a certain range. In the literature view, we have observed our antenna's volume is approximate a little bit high from someone, and the first one, the reference and tray, and in other cases, and our bandwidth of antenna's bandwidth is greater than all the designs that we have used. And also, we have some compromise in terms of gain. Our antenna will be used for what? Implantable medical devices are using gastrointestinal tract monitoring, identification systems, navigation support, gastro applications, capsule endoscopy, skin implementation, biotelemetry, and pacemakers. These are all the applications we can use the design antenna that we have designed. Finally, I'm going to conclude my topic. The paper presents some important features such as the small size, high gain, and wide band, as we checked from this literature review slide. And the proposed design have following specifications which are applied to design the antenna. This antenna has a miniaturized volume of 8 times 8, having overall thickness of 0.2 millimeter 0.1 for the substrate and 0.1 same for superstrate. Superstrate is used on the top of the radiating patch. So the antenna covers the bandwidth of light that we have discussed. The ISM band 9022.928 megahertz with a bandwidth of 178.6 megahertz, and the gain is minus 28.2 dBi at a resonance frequency. And this antenna exhibits the omnidirectional radiation pattern. In the microstrip patch antenna, we cannot achieve the omnidirectional radiation pattern. Instead, we are going to, we are using what? Some techniques. Which techniques? In this design, we have used a shortening pin to miniaturize the size, also to convert the directional radiation pattern to omnidirectional radiation pattern. Thank you for your time today. Here is my email. If anybody wants to contact or ask some questions, please drop an email. Thank you.